The pros and cons of pile foundations. Welcome back to Blueprint to Reality, the channel where we break down the engineering behind the structures that shape our world. Today, we're heading underground, again, but this time to focus on a specific foundation system, pile foundations. They're some of the most widely used deep foundations in the world, but like every engineering solution, they come with both strengths and limitations. So, let's dig into the pros and cons of pile foundations and understand why and when they're used. What are pile foundations? Pile foundations are long, slender columns made of materials like concrete, steel, or timber, installed vertically into the ground to transfer loads from a structure to deeper, more stable soil or rock layers. When the upper soil is weak or compressible, piles go deep to find a firmer base. They can be driven into the ground using hammers or vibratory machines, or bored and cast in place. And, depending on the soil and the load, they can work by end bearing, skin friction, or a combination of both. When are pile foundations used? Pile foundations are used when shallow foundations simply won't do. This could be because the surface soil has poor load-bearing capacity. The structure is very heavy, like a high-rise or a bridge. The structure needs to resist uplift or lateral forces, such as wind or earthquakes, or construction is taking place in waterlogged or coastal areas, like ports and offshore platforms. Advantages of pile foundations. Pile foundations can bypass unstable or compressible soil near the surface and transfer loads to stronger strata deep below. This makes them perfect for areas where shallow foundations would fail or cause unacceptable settlement. Piles can support enormous vertical and lateral loads. In dense urban environments or with structures like bridges and transmission towers, piles offer compact yet powerful support. Pile foundations are incredibly versatile. They can be installed in dry or wet conditions and even underwater, which is why they're common in marine and coastal structures. From skyscrapers to oil rigs, piles provide a flexible solution. Piles can be designed to resist not just downward forces but also uplift, making them ideal for areas where structures may face wind, waves, or seismic forces. Compared to mat or raft foundations, piles require less surface excavation. This reduces disruption and is especially helpful in congested or environmentally sensitive sites. Properly designed and constructed piles, especially concrete and steel piles, can last for decades, even in aggressive soil conditions, making them a durable investment. Disadvantages of pile foundations. Pile foundations often involve expensive materials, heavy machinery, and skilled labor. The cost can be significantly higher than shallow foundations, especially when specialized equipment like pile drivers or drilling rigs are needed. Installing piles is not a simple task. It requires precise engineering, experienced contractors, and coordination. Poor installation can lead to misalignment, damage, or poor load transfer. Driving piles into the ground can cause significant noise and ground vibration, which can be a major concern in urban or residential areas. This sometimes restricts the use of driven piles in sensitive environments. Since piles are mostly underground, it's hard to inspect them after installation. Quality control during construction is critical, as detecting flaws or issues later can be costly or impossible without major excavation. While driven piles are relatively quick to install, bored piles or drilled shafts can be time-consuming, especially in difficult soil conditions. Managing slurry, casing, or water intrusion can delay the process. Pile installation can disturb the surrounding soil, sometimes causing heaving or displacement. In certain soils, this might damage nearby foundations or underground utilities. Also, if not designed properly, piles may corrode or deteriorate over time due to chemical reactions in soil or groundwater. Types of piles. Another factor in deciding whether pile foundations are the right choice is selecting the correct type. Common pile types include precast concrete piles, strong and durable, but heavy and hard to transport. Steel piles, great for driving into hard soils but prone to corrosion. Timber piles, cost-effective, but only for light loads and short-term use. Board piles, more adaptable but slower to construct. Each has its own pros and cons, so the geotechnical report and load requirements play a major role in the decision. Real-world applications. Pile foundations are everywhere, literally under our feet in many places. They're essential for skyscrapers in cities with soft soils, bridge piers across rivers and valleys, offshore wind farms and oil platforms, railway and metro systems, especially in tunnel zones, and waterfront structures like docks and harbors. A great example is the Millau Viaduct in France, one of the tallest bridges in the world. Its towering piers rest on deep pile foundations that penetrate deep into the bedrock, anchoring the massive structure against wind and seismic activity. Conclusion: pile foundations are one of the most powerful tools in a civil engineer's toolbox. They extend the reach of modern construction to places where shallow foundations would never work, under rivers, on weak soils, and in hurricane zones. But they come with trade-offs: cost, complexity, and construction challenges. Like most engineering decisions, choosing pile foundations requires careful analysis, balancing safety, function, environment, and economy. Thanks for tuning in to Blueprint to Reality. If this deep dive helped you understand the world beneath our buildings a little better, be sure to follow for more insights. From the ground up, we build smarter together.